Hey guys, Mr. B here again, and I'm bringing you another line of X video, or line of U as I have on the screen here. In the last video I just made, I did some basic easy derivatives of line of X where you had to use the chain rule. In this one, I'm going to discuss logarithmic differentiation. In logarithmic differentiation, we sort of use our rules of logs to be able to make something that's difficult to differentiate easier. So um, generally, a rule of thumb that I use is I never ever take the log, L-O-G, of both sides in doing this stuff in derivatives. I always take the ln of both sides. And the reason I do that is because the derivative of ln is easier than the derivative of log. So the derivative of log has that pesky log of whatever next to 1 over x. So the derivative of ln, as you can see on the screen here, doesn't have that. The derivative of ln is just 1 over x. So that makes it really, really nice. Can I say that? Really, really nice to work with. So I know it's a little bit nerdy, but that's the best way to think of it. Um, so I showed this in my last video as well, so I might use it in this one. This is sort of an easy, I won't call it a trick, because it's definitely not a trick. It's a definition, and it's easy to do the chain rule with ln in it. So if you have something inside the ln, u, that equals 1 over u times u prime, or du over dx. So if you're not sure on how to use this rule, I'll be using it in this video. You might want to check out my previous video I just did. Look it up on my channel, Math with Mr. Barnes, and it's there. All right, guys, so let's have a look at this example. And this is sort of like textbook example. See it on a lot of first-year calculus exams. And really the form of this is y is equal to a function f of x to the exponent another function. So f of x to the g of x we could write, or whatever way you wanted to write it. So when you have something like this, you really, really are forced to use logarithmic differentiation. So the first step when you do that is take the ln of both sides. So let's do it. So ln of y is equal to the ln of x to the x. So at this point, you have to think back to your pre-calculus classes when you learned all those rules of logs, and you're like, "Why do I need to know all these things?" And well, if you're going on with a math degree, this is why you need to know them, because when you're solving one of these guys, you use your rule of logs with constants and exponents. So the rule is, if you have something inside a log, and ln is a log, don't get that confused. The same thing. The rules of log apply to ln. Remember that ln is just log base e to the x. So that's the same as a log. So all those rules apply. It's just that ln is with a special base. So anyway, let me get back to it. So if you have a log with something inside of it, doesn't matter if it's an x or a 2 or whatever, and it has an exponent, that exponent can come and go on the outside here. So we can just, put that out here, just like that. So it rewrites to ln of y is equal to x ln of x. So it becomes a much easier derivative to use, to take when we do that. So, that works in reverse too. If I had something out here, we could throw it in and put it on top there as well. So now, whereas if I did the chain rule, I would still have to take the derivative of what's inside here, but now I can use the product rule because I have a function times another function, so f times g. So in order to do that, though, what I need to recognize is this is not an explicit function. This is an implicit function, because this is not y equals, it's ln of y is equal to x times ln of x. So that's implicit. So it's not in terms of y equals. So what we do, and you need to write this step if you're on a calculus exam, show the professor or whoever's grading your teacher, your tutor, that you know what you're at, right? So you want to show this is an important step, that you're taking the derivative now of both sides. So the derivative of y, so this is no different than the rule that I just showed you. So the derivative of ln of y is 1 over y. And because this is in terms of x, we have to put that y prime here. So it's the derivative of what's inside. So 1 over y times y prime. And I'm going to use the product rule here. So if you don't remember the product rule, it's f times g prime plus g times f prime, or reverse order, whatever order you want to put it in. So this is my f, and this is my g. So f is x, the derivative of g, which is ln, is 1 over y, plus g, which is ln of x times the derivative of x, which is just 1. So I'll put it there, but you don't really need to. Whoops. All right, so now I'm going to do some simplification over on this side so you can see my x's will cancel. So I'm still got 1 over y times y prime, and that's equal to 1 plus ln of x. So I want this in terms of just y prime, so I got this 1 over y. So in order to get rid of it, I just multiply both sides by y. So what that leaves me with, well, I'll actually write it out. So times y times y. So what happens here is this y and this y cancels. So really, it's kind of a fruitless step, but it is what it is. So I'm left with y prime, and I'm just going to pop this guy out in front because that's where I like to have it. So y times 1 plus ln of x, just like that. And then I got this y left here. I don't want any y's left. I want everything in terms of x and y prime only. So I know my y is equal to my original function, x to the x. So what I'll do is I'll just take y prime is equal to x to the x and stuff that right back in there. 1 plus ln of x. And there it is. That's all she wrote. So there's my derivative using logarithmic differentiation. I guess you could call it ln differentiation, which is kind of what I use. And that's not too bad, right? That's not, I don't think that's a really difficult thing to do, especially not when you have a function that's, I don't want to call that straightforward, but it's not too difficult. So let's try with another one that's slightly different, maybe a little bit harder. So this is y is equal to x to the cos of x. So again, this is f of x to the g of x. So two different functions. The function is the base, and then another function as the exponent. So let's do the first step. Ln of y is equal to ln of x cos x. And again, you want to show this step, let your prof know you know what you're at. You're doing logarithmic differentiation. So then we'll use our rule of log where we take the exponent and we plop it out front. So this gives us cos of x ln of x, just like that. So again, now, those are multiplied together too, by the way. This is a much easier derivative to deal with than, say, the one that we started with. So now what I do is I write this step again. We're showing the prof that we know what we're at. Half the time, that's half the battle. Ln of x. So again, over here, I have the product rule. So what I could do now is, well, I know what this derivative is. We just did it. 1 over y times y prime is equal to, now I use f and g, so the product rule is f g prime plus g f prime. And if you're not sure on this one, I have a video on the product rule as well, guys, so you can go back and look at that. So cos is f, so cos x times g prime, which is 1 over x, that's the derivative of ln, plus ln of x times the derivative of cos, which is negative sine of x. Hopefully you remember your trig derivatives. And then I'm not going to bother to multiply both sides by y because we just did that in the last video. Just trying to save a bit of time here. So I'll end up with y prime, and that goes out front here. You can also think of the cross multiplying just in one direction. And then I'll just, tidy this up a little bit over here. So I'll write it as cos x over x minus, so that minus right there, now change that to a minus, of ln of x times sine of x. And now I'll replace that y with my original function. I want it in terms of just y prime is equal to, and then only x. So the original function was x to the cos of x, I think. Yes. And that's just cos of x over x minus ln of x times sine of x. And there it is. That's all it is to it, guys. So again, the key with this stuff, like I always say in all my videos, is you need to practice. So go now, Write down the two questions, try them on your own, see if you can get them, and then try my next video, which has some harder examples in it of using logarithmic differentiation and trying to use your rules of log. So this is just an intro video, but look at some of my other videos. I'm sure they'll help you. All right, guys, take it easy. Good luck in your studying. You can do it.